Where does the energy from the sun go once it hits Earth? This question dives into one of the most misunderstood concepts in physics, entropy. It's fascinating how the Earth gets a daily dose of energy from the sun, vital for life and various natural processes. But what happens next? Does this energy just vanish? Or is there more to the story? Every single day, a huge amount of energy from the sun makes its way across space for 93 million kilometers and arrives at our planet. It is the lifeblood for almost everything that happens on Earth. It warms our planet, powers the weather, helps plants grow, and so much more. But have you ever wondered what happens to all that energy afterward? Where does it go? First off, it's important to know that not all the sun's energy stays on Earth. Some of it bounces right back into space the moment it hits us. Things like ice, snow, and even some areas of desert are good at reflecting sunlight. The energy that doesn't bounce back gets absorbed by our planet. The oceans, the land, even people and animals soak up some of that solar power. Once something absorbs energy, it doesn't just disappear. It changes into other forms and gets used in different ways. For example, when the ocean absorbs heat, it doesn't just get warmer. The heat helps water evaporate, turning into clouds and eventually rain. Plants have their special trick. They take in sunlight and turn it into energy that they can use to grow, a process called photosynthesis. And this isn't just good for the plants. It's how they produce oxygen for us to breathe and food for us to eat. So, in a way, the energy from the sun keeps moving around, changing forms, and powering all sorts of processes on Earth. Scientists say that the amount of energy Earth gets from the sun is equal to the amount it sends back into space, just in different forms. It's all about balance. If too much energy gets trapped, Earth gets warmer, which is part of what's happening with climate change. How was it discovered? Way back in the winter of 1813 in France, a time full of chaos with Austria, Prussia, and Russia all knocking at France's door. There was this young guy, Sadi Carnot, just 17 and already itching to defend his country. He even wrote to Napoleon, hoping to join the fight, but got no answer. Yet, when Paris was under threat, Sadi got his chance, fighting with his fellow students to defend a chateau. They couldn't stop the invasion despite their courage, and Paris fell. Fast forward to 7 years later, Sadi, now more mature and thoughtful, is visiting his dad, who was not just a general but also a physicist. They talk about steam engines, the cutting-edge tech back then, crucial for powering all sorts of things from ships to mines. The French engines weren't up to scratch, especially compared to Britain's, and Sadi, fueled by a blend of national pride and curiosity, decides to crack this problem. For 3 years, Sadi dived deep into studying heat engines, imagining how an ideal one would work, free from any friction or energy loss. He dreams up this engine with 2 big metal bars, one scorching hot, the other ice cold, with a chamber of air between them where all the magic happens. By heating and cooling this air, pushing a piston up and down, this engine could keep turning a flywheel round and round. Sadi realizes something groundbreaking. Even this dream engine can't be perfect. Its efficiency, how much work it can do with the energy it gets, depends entirely on how hot the hot side is and how cold the cold side is. To be perfect, you'd need the hot side to be as hot as possible or the cold side to be as cold as the universe allows, which just isn't possible. Rudolf Clausius comes along later and talks about entropy. This idea of entropy tells us why things like Sadi's engine can't be perfect and why we can't just recycle the same energy over and over without losing some along the way. Back in the beginning of everything, right after the Big Bang, back then the universe was simple and ordered, which means it had very low entropy. But as things like stars and planets started to form, the universe got more complex and entropy increased. Now, let's talk about black holes, those mysterious spots in space that swallow up everything. These cosmic mysteries do more than just swallow stars and light. They're entropy superstars because of Hawking radiation. named after the brilliant physicist Stephen Hawking. This process helps black holes add a lot of entropy to the universe, making them much more than just cosmic vacuum cleaners. By increasing the universe's entropy, they help us understand how everything works on a grand scale. They're not just destroying, they're also contributing to the universe's evolution and teaching us more about the fundamental laws of physics. Before we move forward, subscribe to our channel as we take you on a trip to the world of physics. Hit the bell icon to set sail on a journey to unravel the secrets of the universe. Entropy has a rule that says things in the universe naturally move from being neat and ordered to more mixed up and messy. This rule helps us understand why we see time as always moving from yesterday into tomorrow. For example, when you stir milk into tea, it spreads out and mixes together, and you can't separate them back into just milk and tea easily. Or, if an asteroid crashes into a planet, the crash can't be undone. These things can't go backwards, which is a big part of how we know what's in the past and what's in the future. Entropy is also the reason why time travel isn't possible. Fast forward to the distant future, and we reach a scenario called the heat death of the universe. It's a phase where all the energy is spread out evenly and there's no more heat or movement. Everything reaches a standstill. But don't worry, this is so far in the future that it's almost beyond imagination. Now, you might be wondering why all this talk about entropy matters to us. Entropy is a big reason we have such a complex and beautiful universe around us. The energy from the sun, with its low entropy, beams down to Earth, giving life to plants. These plants are then eaten by animals, and just like that, life thrives, weaving a web of energy exchange and transformation that increases entropy. While entropy increases overall, it also creates pockets where interesting things happen, like life on Earth. We live in an exceptional time and place where energy from the sun can be used to fuel all sorts of processes, from photosynthesis in plants to powering human civilizations. As we look to the complexity of the universe, from the tiniest atoms to the vastness of space, we see entropy in action everywhere. It's a force of change and transformation, driving the universe forward and shaping everything we see and experience. In the vast stretches of cosmic time, our current state, with its rich complexity and vibrant life, is a fleeting moment. It's a unique chance for us to witness and appreciate the wonder of a universe where stars shine, planets orbit, and life blossoms, all thanks to the complex dance of energy and entropy. Understanding entropy doesn't just change how we view black holes or the distant future. It changes how we see everything around us. It teaches us that while the universe is heading towards a more disordered state, it's this very process that allows for creation, growth, and the emergence of complex structures. So, next time you bask in the sunlight or gaze at the stars, remember you're witnessing the unfolding story of the universe. A story of energy flowing, transforming, and giving rise to everything we hold dear. It's a story that reminds us of our place in this vast cosmos and the fleeting beauty of our existence within it. Through entropy, we find a deeper connection to the universe and a profound appreciation for the intricate ballet of energy that animates the world.